All right, welcome back everybody. Here's our second video on evaluation of functions. We're going to pick up right where we left off. We ended with example 3. So let's go ahead and we'll jump right in here with example 4. Given the functions h of x equals 4x plus 3, g of x equals x squared minus 5x, and f of x equals negative 3x, evaluate the following. First, we've got g of h of negative 2. So we're going to rewrite this as g of h of negative 2. And now instead of going through and evaluating h of negative 2 separately as I've done for the first couple examples, I'm just going to do it in line here. We're going to go ahead and put h of 2 inside these, h of negative 2 inside of these parentheses. So h of x is 4x plus 3. So we're going to take 4 times negative 2 plus 3. And that's going to be inside the function g. Now, of course, I want to simplify this first. And I work it down and get to the point where now I'm finding g of negative 5. Okay, and so then we are going to take g of negative 5, and we're going to put negative 5 in here for x. And we'll go ahead and calculate. And we've got negative 5 quantity squared is positive 25. Negative 5 minus 5 is positive 25. And so we end up with g of h of negative 2 being equal to 50. There's our answer. All right, part B. Oh, wow. Hey, now in this one, we're working 3 functions in composition. And so we're going to work our way from the inside out. First, we're going to find g of 2. And we're going to leave everything else inside there. So this is going to be f of h of, and now we put 2 in here for in g. That's 2 squared minus 5 times 2. Close up all my parentheses there. And then I'm going to calculate what this is equal to. 2 squared is 4. 5 times 2 is 10. And so this is going to be f of h of negative 6. Now we continue working our way from the inside out. We're now going to put negative 6 into h. h is 4x plus 3, so that's going to be 4 times negative 6 plus 3. And we calculate that. So that's going to be equal to f of negative 21. And then we're going to put negative 21 into f in place of the x. And we end up with 63. And so therefore, f of h of g of 2 is equal to 63. All right. So we've done a bunch of examples so far where we're finding the values of compositions of functions at a particular point. What we're going to do in the next example is we are going to find these compositions in general. And so our result, our answer here, instead of being a number, is going to be an expression of x. So let's take a look at what that looks like. Okay, first of all, we've got fog notation here. I'm going to rewrite this as f of g of x. And now, since I'm not finding g at a number, I'm not going to substitute a number into g. I'm just going to bring g and put it right here in these parentheses. So I'm going to replace the g of x with what it's equal to. It's equal to negative 2x squared plus 9. So this becomes f of negative 2x squared plus 9. And now what I want to do is I want to take this and substitute it into f in place of x. So I'm going to take 3x plus 5, and I'm going to replace the x with what I'm substituting into that function. And now I just need to simplify from there. That gives me negative 6x squared plus 27 plus 5. And so it should give us negative 6x squared plus 32. All right. Now in the next one, I'm doing the composition, but in the opposite order. We're finding g of f of x. So we want to put f of x inside of the function g. So we're going to put 3x plus 5 in here. We're going to replace f of x with what it's equal to. And now we're going to substitute that into the function g of x. So this becomes, I already wrote that line. This becomes negative 2. And then I'm going to replace the x with what we're putting in, 3x plus 5, quantity squared. And of course, we want to think about this quantity 3x plus 5 quantity squared as 3x plus 5 times 3x plus 5. Now, I can either multiply these out and then multiply the negative 2 through, or I can multiply the negative 2 through the first factor. It doesn't really matter as long as I only multiply one of the factors by negative 2 if I opt to do it that way. That's what I'm going to do. I'm going to multiply the first 3x plus 5 by a negative 2. And then I'm going to FOIL this out. That gives me negative 18x squared minus 30x minus 30x minus 50. I still have that plus 9. And now I just need to combine my like terms. It gives me negative 18x squared minus 60x minus 41. And so that's what g of f of x is equal to. All right, continuing on. Example 6. Given the functions f of x equals x squared minus x plus 2 and g of x equals 2x plus 6, evaluate the following. So we're doing f of g of x plus 3. Oh, that's very poetic. So the first thing I want to do is I want to put x plus 3 into the function g in place of x. So I'm going to take this and I'm going to replace this x with an x plus 3. And then I'm going to go ahead and I'm going to simplify what's inside here. So that's distribute that 2 through there. And this becomes f of 2x plus 12. And now I'm going to take f of 2x plus 12. So I'm going to take 2x plus 12 and put it in this function everywhere where there's an x. So this is going to be equal to 2x plus 12, the quantity squared, minus the quantity 2x plus 12, plus 2. And again, remember, this is 2x plus 12 times 2x plus 12. So now I'm going to go ahead and I'm going to multiply that out. And that gives me 4x squared plus 24x plus 24x plus 144 minus 2x minus 12 plus 2. And now I'm going to combine my like terms. 4x squareds are my only x squareds. My x's, I've got 24, 24, and negative 2. Those combine to make 46 x's. And then my numbers, I've got 144 minus 12 plus 2. That's 134. And so that is f of g of x plus 3. Over here in part B, we're doing g of f of x minus 5. So we're going to put x minus 5 into f first. So this is going to be equal to g of, and we put x minus 5 into f here. So that's x minus 5, the quantity squared, minus x minus 5 plus 2. And we go from there. This is x minus 5 times x minus 5. And so that's x squared minus 5x minus 5x plus 25 minus x plus 5 plus 2. And we combine all of our like terms. It's going to give us x squared minus 11x plus 32. And then we want to go ahead and substitute that into g of x in place of x. So it's going to be 2 times the quantity, x squared minus 11x plus 32 plus 6. We distribute our 2. And combine our like terms. And there's the value of g of f of x minus 5. All right, let's move down to the try it problems. You see 2 problems here. What I'd like you to do is read those problems. Go ahead and pause the video and read those problems, and I will be back in about 5 seconds from where you pause. Go ahead and pause now, and I'll be back. All right, let's take a look at what happens in these try it problems. Hopefully you took the time to try them. So first we're going to find f of g of x. That means we're going to put g of x in here in place. So that becomes f of x plus 1. And then f of x plus 1 means we're going to replace the x here with an x plus 1. And so f of g of x becomes the square root of x plus 1. Over here, we're going to replace f of x first. And then we're going to put the square root of x into g in place of the x. And so that becomes the square root of x plus 1. Here the plus 1's outside of the radical. Here the plus 1's inside of the radical. All right. On to the last page. If f of x equals 2x, g of x equals x plus 5, and h of x equals absolute value of x, write each function as a composition of f, g, or h. All right, so looking at the first one, capital F of x equals absolute value of x plus 5. Looking at this and looking at the functions that we have being involved, there's an x plus 5 in here, so we're probably going to use g of x. And there's an absolute value here, so we're probably going to use h of x. So the only question is what the order is that we apply those functions. Okay? The last thing we're doing when we calculate the value of capital F here is taking the absolute value. And so that's going to end up being our outer function when we write this as a composition. And so I'm going to go ahead and write this. This is going to be h of g of x. And just to confirm, if we put g of x in here, this becomes h of x plus 5. And then we put x plus 5 into the function h. And we get the absolute value of x plus 5. So this is how we write example 7. Go ahead and pause real quick and give the second part a try and come back in about 5 seconds when you are ready to see the answer. Go ahead and pause now. All right, here we go. G of x equals 2x plus 5. That's going to be a combination here of the function f and the function g. Which one gets applied first? Well, we're putting 2x into the function x plus 5, so that means we're doing the 2x first. And so this should be g of f of x. And just double check. So g of, we'll put f in here, and then we put 2x into g of x, and that becomes the 2x plus 5 that we desire. Okay, what I'd like you to do now is pause the video and go ahead and complete the summarizer question, and then we'll come back after you come back and we'll look at I'll let you look at the answers to these. All right, so go ahead and pause your video now, and when you come back, we'll look at the answers. All right. All right, here we go. Finding f plus g of 2, that's equal to f of 2 plus g of 2. And then we can look those values up at the top of the page. F of 2 equals 7. G of 2 equals -1. 7 plus -1 equals 6. So that's the value of f plus g of 2. G of f of 0, this is a composition. So we need to work in the inside first. We need to find out what f of 0 is. F of 0 is -1. So we'll replace f of 0 with a -1. Now this tells us find g of -1. G of -1 is -4. All right, scrolling down. Then we're going to do f of g of 2. We want to replace g of 2 with what it's equal to. G of 2 is equal to -1. So the value of this is going to be equal to f of -1. And I can read that value is 4 from my values. And then the last one, f minus g of 7. So that's going to be equal to f of 7 minus g of 7. The value of f of 7 is 1, which we can read from our list, and the value of g of 7 is 4. This is 1 minus 4, or -3. Those should have been the values for your summarizer there. All right, homework at the bottom of the page. Go ahead and start working on it, and I'll see you folks next week. All right, goodbye everybody. Have a great rest of your day.